Okay, so let's look at an introduction to this topic on networks. So just a reminder, you have done some work on this before. So a network is a collection of vertices. So vertices are the points, okay? Vertices are points, and edges, which are the lines, okay? Vertices are also called nodes, okay? And these are the points on the graph, and edges are the lines that connect the vertices. And a network can also be called a graph. So copy that and come across. So often the edges are not simply connectors, and they can actually represent things. So a quantity is something that can be measured. Whenever you see the word quantity, it just means a measurement. So we can measure distance, time, money, or anything that can be measured. Okay, so copy that, come across. Again, not critical, but a cycle or a circuit graph consists of a single cycle, and Cn denotes the cycle graph which has n vertices and n edges. Okay, so copy that, come across. Okay, so for instance, there's just one edge, so that's called C1. There's two edges and two nodes, C2, and 1, 2, 3, 4, and 4 edges, that's called C4. So they're not critical, but we'll just have it in our notes anyway. Okay, come across when you're ready. Okay, so to build a tree, we begin with a single vertex and then add edges and vertices. So for instance, if I've got a 4, I could have, okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So each of these have 4 vertices and 4 edges. But when we have trees, we can't have loops, cycles, or parallels. Okay? So we can't have what we had on the previous page to have a tree. So these are trees, which is slightly different. If a graph has n vertices and one less edge, then it has to be a tree. Okay, so if you have one less edge than the number of vertices, so for instance, we got 1, 2, 3, 1, 2, 3, 1, 2, 3. So if we've got 4 vertices and one less edge, we must have a tree. Okay, copy that down, come across. Okay, so in this one here, you have the first one is no good because we've got parallel, so it's not a tree. Okay, here we've got a loop, so it's not a tree. Okay, and here we have a cycle, so that's not a tree. Again, like you've got 2 vertices and 2. We've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we've got the same number of edges. So when edges equals vertices, it cannot be a tree. Alright, got one more slide to go. Copy that, come across. Okay, so the advantages of trees within a network is that the tree can determine the most efficient, or efficient, this means lowest distance, lowest cost or whatever, of doing some task, which is what the whole topic's going to be about. Okay, that's the introduction done. Okay, look out for some exercises. Bye.